So, what if the only ice cream flavor was vanilla? Well, that's pretty boring. Hydrocarbons are boring. So we need to spice them up. We need to incorporate some functional groups and, get those flavors that are not vanilla. So how many carboxylic compounds are defined by the presence of functional groups? Many, 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 and many. So these are the ones that you're sort of going to need to know. Now, they are in different colors for different reasons. Haloalkanes are like everywhere, everywhere, everywhere. You need to know that super well. The ones in red there, you also need to know super well. They come up all the time. Both of those, you need to know how to name, number, write out, identify, everything. I put haloalkanes in green because they are the most common. The blue ones there, amines and amides, are slightly different. This is on the basis that you need to know how to identify them. You need to know how to identify them when they're named. So if you're given the name of the molecule, you need to know how to identify that it's an amine or an amide. You need to know the general structure of them. But if you're given a picture of one, so you're given a picture, and the picture, is like it's an amide or an amine, and you can tell that, you don't need to know how to write out that molecule. You don't need to say, all right, this is 4-pentine, like it's like pent-4-ene 1 amine. You don't need to know how to draw. You don't need to know how to name that. You can be given one, and you can identify it as an amine. You don't need to know how to name it using the IUPAC. For amines and amides. So they're slightly different in terms of they just put less sort of push on you to do that. It's also the same with aldehydes and ketones. The only reason I put them in here is because they're quite useful when it comes to our pathway of alcohols to carboxylic acids. Now, again, you don't need to know how to name them. So you don't need to know how to go, all right, that is pentan 2,1, or that is pentanol. So pentanol would have, an aldehyde group on the end. You don't need to know how to name those given if you were given the image again. Same thing as amides and amides. The only difference there is they're really useful when we look at alcohols to carboxylic acids, and you kind of need to know how to work with them a little bit more than amides and amides. Amides and amides become important when you get to food chem. So again, don't need to know how to name them, and even in food chem, you don't need to know how to name them, but they do come up in food chem, so they kind of get more influence in food chem, and they get more of like a, hey, look at this, you need to know about this, rather than right now. You do need to know these reactions as well, but we will talk about them when we get there. So, moving on, let's start with haloalkanes. Most common is chloro. It's always going to be chloro. If they give you something else, well, it's not that bad. You're going to know how to work with it, but that's a little bit annoying because they usually only give chloro. It's the presence of a halogen group or a substituent that changes the reactivity. They're used as sort of synthetic precursors because it's really easy to add these things on to just basic hydrocarbons. And then from there, that makes it easier for that to sort of add something else on that you want. As you can see here, we just add chloro in. So we just say, hey, chloromethane. This one's a really complex one, so it says like, hexachloro ethanes because there's 6 of them. You're never going to have to add 6 in, don't worry. And then here's a benzene ring that has a chlorine added to it. So we say chlorobenzene. Now, I do want to look at this skeletal structure very quickly. Ignoring this benzene ring is a little bit different in terms of that. Ignore the benzene part. This skeletal structure shows that there is a carbon here. There's a carbon here, carbon here, carbon here, carbon here, carbon here, carbon here. Now, ignore the ring. This little section here, is there a carbon here before that chlorine? There isn't. Why is that? Because at the end, they've drawn a molecule. So when you have a skeletal structure, if you draw a molecule at the end, so you say, I'm working with molecules like this, and then I put OH at the end for an alcohol. What I'm working with here is a prop, not a bute, I'm working with a prop. If I'd just drawn this, that's bute. But because I put the OH here, it becomes a prop, and that is propanol, or propan-1-ol. That is just saying that there is an OH off this carbon. So you have to draw that extra line, and you have to make sure you know that that's not actually a carbon again. So then alcohols, as we just talked about, alcohols have an OH group. The most common is ethanol. Ethanol is used in lots of things. It's used as fuel. It's used in alcohol, as in like drinking alcohol. Methanol is mainly used in sort of hand washes, those the hand sanitizers we've all been, loving over the last 2 years. That is methanol. And then you have sort of propan-2-ol. So propan-2-ol here is just another version of an alcohol. Now, alcohols have OHs. The really cool thing about alcohols is you also have this thing called primary, secondary, and tertiary. What's that mean? Primary alcohols have the carbon that the alcohol is connected to only has one carbon coming off it. So what we're talking about is this carbon here only has one carbon coming off it. This carbon here, which has the alcohol on it, has 2 carbons coming off it. This alcohol here and this carbon has 3 coming off it. Now, I don't know why I put 1, 3, 2, 1, 2, 3, you know what I mean? So this is primary, this is secondary, and this is tertiary. 1, 2, 3. As you can see there, 1, 2, 3. So that carbon has 1, that carbon has 2, that carbon has 3. And so there are different things you can do with these alcohols. So please remember them. We are going to move into how we work with them in a little bit, but do remember them because it is an important rule to know. So, ketones. So these are really important. You don't need to know how to name them for VCE. However, they do end in 1. So they go 1. That's their suffix. They do have a prefix as well, but we don't worry about it because, as I said, you never need to know how to name them, and usually most of the time they're sort of by themselves. Now, a ketone is a carbonyl group. A carbonyl group is a double bonded oxygen. This is a carbonyl group, and a carbonyl group that's bonded secondarily. So it cannot be tertiary. So first of all, cannot be tertiary. Why can it not be tertiary? I want you all to take 10 seconds to think about that. Why can a ketone not be tertiary? Because it's got a double bond. Pretty simple. If I have a carbon with a double bonded oxygen, I can only maximum add 2 more bonds. I can't add a 3rd bond for 3 carbons. That's just wrong. It's just bad chemistry. It's a sin. So what's really important about these is understanding they can only be secondary because if it's on the end, that's an aldehyde, and we'll talk about that in the next slide. So ketones are carbonyl groups found in the middle of a molecule, and they are always secondary. So they're always secondary, and they end in 1. So you do need to know that they end in 1 because you may get a question that says, pentan 1, and then you need to identify that's just a ketone. Now, aldehydes, on the other hand, they're the same thing, but they're on the end. So they're always primary. So instead of having a primary alcohol and a secondary alcohol, and instead of having, a primary carbonyl and a secondary carbonyl, we have an aldehyde and a ketone. They've got their own names. Aldehydes are far more useful. We use aldehydes in things like formaldehyde, if anyone has heard of that. Formaldehyde is what we use to preserve dead tissue. So we preserve bodies. We preserve, like when people have their dead animals in like a tank that uses formaldehyde. You will have heard of formaldehyde before, I'm sure, at some point. It's used in lots of those like crime TV shows and things like that. So formaldehyde is really the most common aldehyde that's used. Aldehydes are really, really useful. And we'll discuss why in a little bit, but they are primary. They end in al, so you might have pentanal, or in this case here, you've got ethanal. So in this case here, this molecule is ethanal. Usually you don't need to number these ones because it's always on the end and they're usually by themselves. So you don't need to bother numbering them. But if in some complex reason you've got something else there, you're going to have to do some numbering. But don't worry, it usually doesn't need numbering. But as I said, you don't need to know how to name them for VCE. But just a cool sort of fact. Now, carboxylic acids. Now, carboxylic acids use the suffix oic acid. Now, these are the most common ones that come up. These are really, really, really important. So please understand these out of today. So a carboxylic acid has the suffix oic acid. It does not have a prefix. Now, you do need to know how to name these as well. They do not have a prefix because they are the highest priority. These are the highest priority. these will always be number one. You will always count from the end with the carboxylic acid. Now, why do I say count from the end with the carboxylic acid? Because carboxylic acids are always at the end. They're never, ever anywhere else. They're always at the end. They're always one. So you are never going to write propan-1-oic acid. You are never going to put that one in there. Why is that? Because it's always priority one. We always know where it is. It's always going to be at the end. As you can see here, this is an really good example because it's got a methyl group. We've given the methyl a number, but the oic acid we haven't because the oic acid is always on the end. Again, here, propanoic acid. Same thing, it's always on the end. It also has a space between the oic and the acid, really important. I know how I said before there's no spaces. This is one of those ones where there is a space because it's a separate word. You're adding acid as a separate word, so it's oic acid. Really important you put a space there. So these are always priority number one. Then we have esters. Now we will discuss how esters form, so please don't worry, we are going to talk about that. But esters sort of form from alcohols plus carboxylic acids. What I want you to get out of this slide is how to name them. So esters have this cool C-double-O bond. If you are asked to write a semi-structural formula, so this one here, example, you're asked to write a semi-structural formula, you are going to write CH3, C-double-O, CH2, CH2, CH3. Sorry, I ran out of room. But that is how you would write the semi-structural formula for that molecule. You don't need to go, CO double bond O, a double bond to an O. You don't need to put the double bond in there. You're just going to write C-double-O. That is how you semi-structurally write an ester. Now, esters are really cool. They come up all the time. Huge in food chem as part of our proteins and our also huge in our fuels because they're really, really important in our biofuels. And you've already discussed that, but you'll discuss it further in food chem because it comes up again. What's really important is they have two words. This is split up again into two words, and it's ill await. Now, also kind of cool, they sort of with the alcohol, unless there is any like double bonding or triple bonding, so unless you've got like an alcohol that was like this, and then you had your OH group here, unless you had like this, and this will never happen. I'm just saying it could happen, but it's never happened, and I doubt it will ever happen. You are always going to have alcohols that are single bonded. You're always going to have ane alcohols. So for the sake of VCE, when your alcohol, for this case, we're going to use this one. So we'll say this is propan-1-ol. We're happy with that. It's propan-1-ol. So propan-1-ol, as part of your alcohol part of your carboxylic acid, is going to form propyl. You're not going to put the ane in there. You're going to get rid of it. You're just going to say propyl. So this is propyl. Then your carboxylic acid. So let's just say, I'm going to rub this one out and draw it here. So then let's say we have a carboxylic acid, and let's just say it is this carboxylic acid. This is ethanoic acid. We're going to write ethanoate. So you keep the an or the ene or whatever it is, you keep that for the carboxylic acid part. A little bit frustrating, but it's just the way things work. When you do have something weird in your alcohol, you then go and change this up. But that is beyond the scope of VCE, and you do not need to worry about that. As you can see here, this molecule here, if I name this one, it's a little bit different. So when I'm naming it, I need to figure out what part was the carboxylic acid and what part was the alcohol. Well, if I say, and I'm going to say to you it splits here. This is where it splits. Which part here has to be the alcohol and which part here has to be the carboxylic acid? It's more which part has to be the carboxylic acid. Which one has to be the carboxylic acid? Hopefully you thought, 3, 2, 1. It has to be this side. Why is that? Because it's got the double bond O. So this side is 1, 2. So my carboxylic acid was ethanoic acid. So I'm going to have ethanoate. What about my acid? Well, my acid was 1, 2, 3. No, sorry, my alcohol. My alcohol was 1, 2, 3. So this was my alcohol, and it was exactly like what we wrote before. It's going to be propyl ethanoate. Now, two words, so there is a break in there. There is a gap, but that is propyl ethanoate. Then last two, amines and amides. Again, you don't need to know how to name these. They very rarely, they do, like this will come up and you'll need to know how to sort of identify it, and they'll have this come up and you need to know how to identify it, but you never need to know how to write it fully down. They end with the suffix amine, or they start with the prefix amino. This will come in handy because you can look at things like amino acids. Ethanamine is another example there, methanamine, etc. Amines can be secondary, tertiary, primary, secondary, or tertiary. What's really cool about this is it comes off the end. So if I write out this molecule here, H, 1, 2, 3. This is primary. Now, if I draw out this molecule here, can I get rid of the? Oh no, I can't. If I draw out this molecule here, I don't need to draw out the hydrogens. I'm just going to, just for the sake of it. This here is secondary. Now, if I draw out, I'm going to come over here. If I draw out this, and then these all have hydrogens coming off it. That last one was terrible. That is tertiary. So you've got primary, secondary, tertiary amines. They do come up, they're a little bit different. And they base themselves off how many carbons come off the nitrogen. Now, amides, these are, again, a bond. So you've got carbons on either end of this, and you've got a chain coming off it. Now, amides are important more for biology than chemistry, but we do talk about them very briefly because there is a peptide bond. Now, they end with amide instead of amine, so their suffix is amide. Don't worry about a prefix, it doesn't come up. These are the links that link together amino acid residues, and you will talk about these far more in food chem for that reason. So, pushing through, here's a really cool summary slide. Now, this is the sort of summary slide that I don't really want you to go and take a screenshot of this and then paste it in your book. What I would want with you, with all of you for this summary slide, is to go ahead and actually do make your own version of this. This is really super useful. It's something that would look really good in not only a workbook or a summary book. It's something that allows you to sort of come back and go, all right, what are some just really good examples? How do I name, what do the groups look like, etc. So it's a really good summary slide for that. It's all the functional groups you need to know. It's got all the names, everything like that. So it's a really good way of going about it. So again, they want you to have your own turn. However, I think what we'll do is, for those of you who are at home, please feel free to have a go at this. I think what's best for those of you at the live stream or the premiere, have a go at this one here. I'll go through these ones, and I will go through this one, but I'm going to give you 30 seconds. I want you to go through this one here only, because in 30 seconds you're only going to get one done, even if you do get one done. Have a go at this one. Your time starts now, so at 12:55 we're going to go through it, as you can see up here. Amazing. All right, that's your time up. Let's go through these. So I'm going to start at the start, and then I'm going to go to the other ones. So starting with this one here, let's go to our longest chain. We've got 1, 2, 3, 4, and then we've got a single chain here. So we've got this is a ester. So we've got an ill O8. So let's figure out which one is the ill. We break it here. This is the ill. So we've got butyl, and then we have meth, because there's only one, so meth and no weight. Butyl, methyl noate, it's an ester. All right, next one here. So what's going on in this one here? So longest chain, 1, 2, 3, 4, 5, 6, 7. Going to count from down here because that's the closest to that. So 1, 2, 3. So 7. 7 is going to be hept. They're all single bonds, so it's going to be ane, and then this is at the third carbon, so it's going to be heptan 3 ol. Oh, whoops, I need to put another dash in there. My bad. Heptan 3 ol. Heptan 3 ol. Now, lastly, this is what I got you guys to do. So 1, 2, 3. So there is a chlorine molecule here and a bromine molecule here. This is closer to the end, so we're going to prioritize from here. They're both the same priority, but because the chlorine is at an end, we may as well count from there. So 1, 2, and then this is the third one. So this is going to be 1 chloro, 2 bromo, but B is before C. So it's going to be 2 bromo, 1 chloro, and then this is going to be propane.